once again, had to squeeze in part 2. So let's just tackle it. Whole different ballgame. Now there's a bunch of rules, but the pre-calc book is introducing you to one kind of these, but then the different variations are going to change as we get deeper and deeper into this book. So pay attention to this. This is level 1. So they say sketch. That means get close. Sketch the graph of this. Well, first of all, we got to look at something called even multiplicity. What that means is that actually I should have said 0.5. Your first step is to find your zeros. So it's like, okay, -1, that's one of my zeros. I know the graph is going to do something there. I know it's 2. I know the graph's going to do something there. And that's a 0, so I know it's going to do something there. Now that we're done with that, now we look at this even multiplicity clue in connection with the second clue. If it's even multiplicity, which means that's an even number, that's an even number, that's an even number, it's going to bounce off the x-intercept. Again, you can always go to Desmos and type it in to confirm your suspicions, but after you've done this a while, the book's going to expect that you do it without a calculator, without Desmos. So these are the rules. It bounces off. Well, how does that help me? Well, it's connected to this. An even function. What do you mean an even function? This is an even function because the power of x is an even number, and I'm going to go with the basic. We know it's a parabola. So what are the extremities? Well, on the far left, it goes up. On the far right, it goes up. That's if a is positive. Notice a is positive. And this one, a is positive. So there's a lot going on. But I'm going to use this clue, and I'm going to go, I know it goes up there, and I know it goes up there. Now, it's not a parabola. You can see that. So why is this an even function? Well, 2 plus 2 plus 2 is 6, which is an even number, which means it's going to obey these same rules. Now the work comes. So we know it bounces off here, so it's going to go like this, and then it's going to come back, or it's going to go higher and come back. And then it bounces off here, so it's going to go like from here, and then here, maybe here. We got to figure this out. How? Well, this is where the work is. That point right there, the halfway point, x is -0.5. To find out where it goes with the y, I have to plug it in. So -0.5 squared, and then -0.5 minus 2 squared, and then -0.5 plus 1 squared. Now I'm going to do the math in a minute. I'm not going to waste your time. I want to figure out how high this goes, so I'm going to let x equal the halfway point, which is 1. A lot easier to plug in. So I get 1 squared times 1 minus 2 squared, and then 1 plus 1 squared. Let me pause this a second. All right, so there is the math. I plugged in -0.5 here, here, and here. I got 0.39. So it doesn't go up very high. It goes up almost to halfway. So it goes here, comes back up, and here. Then I plugged in 1, and I plugged it in, did the math, and I got 2. So that actually goes up to here. And I want you to get out a magnifying glass, and I want to show you a couple things. Remember, this highest power was a 2, and we had a parabola. There's 1 turning point. This, the highest power is 6. And I want you to notice we got 1, 2, 3, 4, 5 turning points. There's always one less bump or turning point than the degree of the polynomial. And that's another rule you can tuck into your back pocket. So there you go, you guys. That finishes up today's lesson.